All right, so I'll kick in now. Reminder everyone, these will be recorded anyway and also chopped up, so you'll be able to watch them over later. So welcome to the third EU UK CLT Toolbox webinar. This is connection detail design of a post and beam office building. So presented by Marco, as you can see this amazing photo here, but I'll take us through some of the first few slides just on what we're doing. So to kick off, today we'll do introductions. We'll do a couple of slides on housekeeping, then introductions. We'll talk about our most recent release and upcoming releases, and then we'll get into the actual design itself. So we visited the International Mass Timber Conference in Portland last week, and so that's us there, and it was an awesome time. So housekeeping wise, you can access full webinar recordings on the community forum, so you can access that anytime. And you can also find calculated tutorials, which are chop ups of this webinar itself on our YouTube. So what we're slowly doing is creating a catalog of education for people to be able to review. So during this presentation itself, you can use this question icon on the bottom of the screen. So I've already enabled the Q&A. So if you have any questions, feel free to drop them into this Q&A at any point during the webinar, and we'll make sure we get to the questions at the end. Jokes are welcome, but we also encourage real questions too. So just very briefly, as we all know, there are challenges for the timber option. And we at CLT Toolbox and all of our partners, we're here trying to create an easier pathway for timber design. So very briefly about us, I'd say most people here know who we are already, but we are a team of 45 software and structural engineers. We release new calculators and feature updates every 2 to 3 weeks. We have calculators for CLT, for GLT, light frame, connections, and we're currently being used in Australia, New Zealand, Europe, UK, and North America. And you'll note that we've said and North America, not launching North America soon, because we launched just last week our beta version for that region. So we're now partnered with over 20 product suppliers to the mass timber industry, and our mission is to build tools to enable the profitable design of timber buildings. This is our goal. Our most recent release, this was our USA and Canada beta. So, you can see the GIF here, but fundamentally we released floors and walls and beams and columns that you can design with NDS and with the CSA in Canada. So as we said, we release every 2 to 3 weeks. So the releases of this magnitude. And don't worry, Europe, we definitely haven't forgotten about you by doing this release. It was just about getting something out there for the market. So for those of you in Europe who do actually also design for the US, we have started our North American beta program, and this is the ordering in which things will be released. So as you can see, it's basically about us slowly taking the calculators with all the Australia, New Zealand region and for the European region, and making them available in the US too. And so we'll slowly be doing those releases over the coming months. As you can see with these upcoming releases, so I think it was last week, we released, as we said, the floor, the beam, the walls, and the columns, a bit of an update to our PDF report and how we manage our grades. Our next release, I think, is on Monday. It will be a simple release, the CLT compression perp to grain and the GLT compression perp to grain. But this release here, planned for April the 21st, is a massive release. We'll be releasing our CLT floor and wall fire module. So that's our new updated fire module, same for beams and columns. We're also trying to release Analysis 3.0, which will include the likes of cantilever and point loads and things like that. And updating the shear wall as well as other aspects of the app. So we're really excited about these changes coming up soon now too. So before anything else, of course, we have to say thank you. We wouldn't be here without them. And we will be announcing these soon, but we have 6 new partners that we'll be announcing over the next couple of months will be coming onto the platform. So by then we'll be pushing up close to, I think, maybe even 25. We're really proud of the development there, and we're really thankful to all of our partners, the ones who are partnered with us and the ones who are here on this call now. So without further ado, allow me to hand over to Marco, who's going to be doing the presentation today. I just want to say thank you again to everybody for coming along. At the end of this, any questions that you ask, we'll be doing a Q&A at the end, and really appreciate your time today. So over to you, Marco.
Thank you, Ringo. So let me just share my screen at the beginning. So, hi everyone again. Thanks for coming and welcome to the third episode of CLT Toolbox webinar series. I'm Marco, product manager here at CLT Toolbox, and I'll be your host again. I'll take you through the detailed connection design of mass timber post and beam office building. So at the beginning, let's take a look at what we designed in the previous episodes. In the preliminary analysis, we designed a typical CLT floor, GLT beams, internal, external GLT columns. We also designed a vertical bracing diagonal with the connections and panel-to-panel connection based on the horizontal analysis and diaphragm analysis that was part of the previous webinar episode. In this episode, we'll look at the connection detail, and we'll first talk about the screw properties and the theory behind the connections and how that can impact the design. Then we'll go through a slab to beam connection design with a slab to timber option, and then with the alternative with a steel beam. And then we'll take with the design of the custom steel bracket design with the horizontal first, and then incline screws, and we'll apply some of the screw theory we're going to talk about in the beginning. The last part of the design will be related to the beam notch design. So let's look at the beginning of the theory of the screw properties and connection design. So some of the basics for the connections at the beginning. So a connection should be designed so they can fulfill the structural, architectural, and assembly requirements of the building. And there tend to be a structure's weak point. So it's therefore particularly important to carefully consider how the joints work statically, but also to look at the joints' effect on the other functions. Also, joints are a load-bearing point of the structure whose task are to connect different components of the structure and to enable elements to work together as they're planned to. Screws are types of fastener used to connect different members, and they're engineered to provide optimal performance in the wood-to-wood or wood-to-steel application with unique thread design, coating, resistant to withdrawal, durability in various wood types, and environmental conditions. Here are some of the main properties of screws. So we have withdrawal capacity, that ensures the screw resists being pulled off. Then head pull through capacity, that is preventing head pull pulling, and the yield bending moment as the main properties of each screw. In the timber structures, elements are assigned to different usage classes depending on the installation location and expected moisture. Service classes, according to Eurocode, defines how timber responds to environmental humidity, influencing the choice of the connection. So according to the current Eurocode, we have 3 service classes described as on the table below. In the new Eurocode, or the final draft, there is introduction of a 4th service class. But for time being, we can look under these 3 service classes as for the current Eurocode. So the first one related to the dry conditions, the second one occasional moisture exposure, while the third is the frequent wetting drying cycle as on the image on the right. Concerning the corrosion protection classes, there are 2 type of classes. So we have C classes and D classes. C classes measures the aggressiveness of the surrounding environment, ranging from C1, that is related to dry and clean environments, to C5, highly corrosive environments such as coastal or industrial areas. They're depending on humidity, air pollution, and chloride contact, and they're according to EN ISO 9223. For the D classes, they evaluate the corrosion potential of the timber itself, from T1, the neutral timber, to T5, that is timber with high acidity or chemical treatments. So that is practically corrosion caused from the wood, and depending on the moisture, type of wood, and pH value, according to EN 14592 standard. Going further, we can talk high level on the screw properties. So the head of the screw can be many types depending on the purpose of the screw to be applied for. Screws can have countersunk heads, cylindrical heads, washer heads, hexagonal heads, and some of the more specific to each producer. Also, washer heads, for instance, have higher head diameters, and they're preferable for clamping of 2 members together, while cylinder heads have a smaller head diameter, and they're preferable if the screws are to be drilled below the surface of the timber member. So practically each type of head are preferable to a certain type of connection. Based on the portion of the thread part, screws can be fully threaded or partially threaded. So fully threaded screws are used to utilize their high withdrawal capacity because of the longer thread lengths and can be used for reinforcement purposes as well. Partially threaded screws are mostly used for clamping two members together, and these screws can be widely used in post beam applications. Also, in terms of application, partially threaded screws are usually used for wood-to-wood or steel-to-wood connections to pull components together, while fully threaded screws are used to transmit high axial forces into timber constructions and buildings. Usually, they're installed in inclined direction with respect to the shear plane and wood grain, and also used as a reinforcement, as I mentioned. Some of the application of these connections can be seen in the images below. In Eurocode, the characteristic load carrying capacity of lateral loaded metal dowel type fasteners are calculated based on the Johansson's theory that is described in the Eurocode chapter 8. The failure modes involve embedment failure of the timber member of yielding failure of fastener. The withdrawal rate also affects the lateral load carrying capacity of fasteners. In Eurocode in general, the final lateral load carrying capacity is the sum of Johansson's part of the equation and the rope effect, which is the withdrawal resistance. So if we go further, we can see all the equations according to Eurocode. So there's five failure modes. There are 6 failure modes. The first 3 involve the embedment failure of the timber due to applied lateral load, and the failure mode D and E are linked with the yielding failure of the screws, and they're occur in the head type or the tip type of the member, together with the embedment failure, and the last failure mode F, yielding failure of the screw, and the embedment failure happen in both members. And then going further, if we look at the inclined fully threaded screw towards the force, which can take the actual force. The interesting is the more we incline the screw, the more it has the axial effect, and the less it has the dowel or the lateral effect. The idea of using the inclined axial loaded screws came with the development of fully threaded self-tapping screws, and particularly because of the benefits that the threads are wide, which gives these screws good anchorage into the wood and have a high withdrawal resistance, and also a very good mechanical interaction between the screws and the surrounding wood. Concerning the applications, these effects of these screws can be applied to timber-to-timber, steel-to-timber applications, timber-concrete composites, and also shear reinforcements. With a resolved system of forces at the shear plane with a simplified truss model, as we can see in the imagery here, the idea behind this is that these connections with a certain angle are predominantly characterized by the axial effect. So the design model is based on the actual resistance of the screw. Also, what is important to note that this model doesn't deny the existence of the dowel or the shear effect of the screws, but the idea that we can safely neglect these screws for the sake of practicality. Here are some of the equations behind the calculation. So we have first the calculation of the characteristic axial capacity of the screws that can be calculated in this particular case as a minimum of withdrawal capacity in the section from the point side member and the characteristic tensile resistance of the screw. The total design axial capacity of the fastener along the lateral load axis can be calculated as the design axial capacity along the screw multiplied by the cosine of the inclined screw angle. Now, as we point out some of the theory behind the calculations, we can discuss now on the and show some of the application of these screws in our platform. So from the previous episode, we designed the CLT diaphragm where we verified the slab thickness, but also calculated the panel-to-panel connections. We also calculated the forces from the diaphragm transfer to the vertical bracing. And now we're going to calculate the connection between the diaphragm and the vertical bracing at that location. So we have the diaphragm reaction of the vertical bracing, we know the length of transferring beam, and we have the design force of 8.1 54 kilometers per meter. So we can go to the app and use this information for calculating the connection. So I'll change my screen, and here we're back in the app. So we have as you're already probably familiar with some of the features, we have separate menu for member and connection design. If we go into connection design and scroll down, you can see that we have a separate connection detail for CLT floor beam calculations. We can go into the new projects. I'll add to my company level project. So for our enterprise users, there is a feature that allow you to share all the calculations with your team. We'll type in CLT Toolbox webinar 3, and we can go with slab to timber connection. So in a second, we'll be redirected to the calculation. So we can start with selecting the proper code and properties of the connection. So as I point out the last webinar, in all our connection calculation, you can switch between the current and the new Eurocode provision. So we implemented already the latest final draft of Eurocode 5, so that is something that can be used for all the connection calculation. It can be very important, especially because the CLT wasn't part of the current, and also a lot of calculations are advanced and new compared to the current one, so it can be interesting in this transition period to check what is happening with the new standard. For the layup, we can choose some of the available producers over here. So at the moment, we have the products from Excellent Dolomiti, KLH, Sodra, Calvasta. We can also use with the custom layup, but let's check with the Sodra products in this stage. We can see all the available layups that are listed here, but for this case, we can go with 5 layers, 180 millimeters layups. Also for the GLT, we can select the type of material, so you can choose between the GLT, LVR, or solid timber. For the supplier, we have products listed for Calvasta, but also we can also go with manual layup as we used in the previous example. So let's select GL24 28C. We'll type in the same the dimensions we have in the previous, so 360 by 720. And we can check the dynamic imagery to see how this aligns. So we have section A, section B. For the floor type, we have option for selecting between the continuous and discrete. As I mentioned on the half lap connection last time, these features are strictly allowing with the calculation to calculate the number of fasteners needed for the total length of the connection. So if we select discrete, we have option for selecting what is the length of connection, but in this case, we'll just use the 1 meter strip. Going further, we have option for selecting the screw supplier. So in this case, we can select any of the supplier available in this stage. So for this example, we'll use the Rotoblas screws. So we can select some of the available product families they have listed here, but we can go with partially threaded TBS screws, and we can select some of the available screws here. So let's start with 6 by 320. For the analytical methods, you can select between the Eurocode basic calculations or with the supplier's ETAs. For all the that you didn't use some of these features, here's the educational content that can be used in any moment. But what also is important to note with the ETAs selection, in this case, calculation will be based on the suggested official document by supplier. So based on the ETA, so all the rope effects calculation, intermediate edge distances, tip types will be included as according to supplier recommendation. For the screw data, we can type in here what are the spacing, what is the position of the screw, so we can use the right and support. For the positioning of screws, we can use, there's an option for selecting, is it flush with member face, center with a horizontal plane, or with custom member plane. In this case, we can go with flush member face, and we can also switch between the vertical, incline, cross screws. In this example, we can go with the vertical one. For the loading data, we'll type in the inputs what we have. So I'll set 8 by 54 kilonewtons only in one direction. For the other direction, we can go with 0. And for the design data, we'll have parameters for Eurocode. So gamma will remain 1.3. For the load duration, we'll go with short term because we have wind in the governing loading combination. We have surge classes 1 and we'll leave a no from pre-drilling. If we go with the results, we can see the geometry checking passes. The shear capacity is failing on 140 or 105%. So we'll narrow the spacing to correct this. But just quickly to see also we have the nodes, minimum beam end distance noted here, and in these geometry checks, we can check all the results in detail. So we have information about the positioning of the screw, all the geometry and recommendations. And in lateral capacity, we have all the information about the calculation. So firstly, the rope effect calculation based on the references from the ETAs. And then in the next part, we have all failure modes based on the mechanism from European yield model. As I showed in theoretically in the previous couple of slides ago, we have now all the information here in detail. So anyone who wants to check calculations can be done here. Also, we have here the summary of all the failure modes. We can see what is the lowest value. We have the information about effective numbers of screws, and the last part is the verification of the connection itself. So what I'll do, I'll just set that we're going to use on 180 millimeters, and I think this will be enough for the design. So it's not 95%, and we can go with this design. I'll just click save, and we can go to the next example. So in this second example, we'll use the pretty much the same configuration. We'll just have assumed that we have steel vertical bracing. So in that case, we'll need another module for calculating the floor to steel beam calculation. So that is part of the alternative scenario. And for this example, we'll use the IPA 400 profile as steel beam. So let's jump back to the app again, and I'll just get back on the project level. Here we'll easily add calculator and find the appropriate calculation. So we have here CLT floor to steel. And we'll create the calculator and start with the calculation now. So again, the selection has is with the same idea as in the previous calculator. We can switch between the current and new Eurocode. We can select the overall layout and thickness. So we'll start with Sodra. We can go with 5 layers, 180 millimeters. We can select continuous. So we'll calculate only the 1 meter strip. For the steel member data, this is something that is at the moment on the manual input. So you need to find out what the geometry on the calculated profile that you're using. For the IPA 400, I'll just type in the thicknesses that we have. So I think this is 8.6. B is 180. We have 400 for the depth. Web thickness, I think that's, I'll just correct this, is 13.5, and we have 8.6. Here, root radius is 21. So that will be applied on the dynamic imagery and also will be included into geometry checks. Now, if we go into screw suppliers, we'll select again Rotoblas. We'll just check what are the steel to timber alternatives. So we have implemented the function of filtering appropriate screws for the connection. So in this case, also, if you're not familiar with some of the products from suppliers are here, you can always use the more information functions where we have information about all the screws, images, but also screw types, head types, threads, diameter, length, service classes, and specification. In this case, we can go with HBS plate, and we can select the appropriate screw. So we can go with 8 by 160. And again, we can select the supplier's ETA. Going further, we have option for the screw position. So we can set this on 50 millimeters. For spacing, we can go with something bigger because we have steel to timber here. So let's go with 300, and let's check the same position. So right end support should be visible here. It is, and for loads, we'll type in Y direction 8.454 kilonewton per meter. For the design code, we have gamma. For load duration, again, we'll select the short term as we have. Service classes will remain on 1, and for pre-drilling, we'll check in for no. Considering the results, we can see the geometry check is passing, but also the shear capacity is easily passing the design requirements. Quickly on the results, we have information about screw geometry, lateral capacity, also starting with rope effect, but also concerning the mechanism types, we have the appropriate one for the steel to timber verification. So we have the beam failures for the thin plate, for the thick plate appropriate. So in this case, we have 5 failure modes for steel to timber application, and on design capacity, you can check what are the minimum values separately for thin and thick plate based on the selected geometry, effective numbers of screws, and the last we have information, shear capacity of the connection. Again, we're gonna set save and go back on the project level. So going further, we're going to look at the design of a custom steel bracket design for beam to column connection. So we're going to use some of the available screw modules for designing of custom connections and show you how you can use and combine separate modules for designing this type of connections. So in this case, we have a hanging GLT beam that we need to connect on the side to a GLT column. We can use this with variety proprietary products, but in some cases, custom steel connections are the best solutions. And this could be because of the architectural requirements, high reaction forces, or because of the other reasons. But in this case, we'll try to design one of these connections. So we'll fix the steel bracket with a set of horizontal screws as described on the image on the right, and we'll have a seated connection while the beam will be supported. We'll add additional screw from the below just for fixing the joint into the right position. So we have a GLT beam 360 by 720, GL24C. We have GLT column 360 by 360, GL24H. We have the maximum factorized reaction force, so 108 kilonewtons for the governing load combination. We have the K mode 0.8 horizontal screws, and we'll in this case use Eurodig plate screws. So we'll jump back to the app. We'll select the appropriate calculator module. So in this case, we'll select one of the screw design modules. So let's start with lateral loaded lateral loaded steel timber side grain. So let's start with the design. Again, we can choose between the current and new Eurocode. We'll stick with the current Eurocode at the moment. We'll type in the properties of the connection. So let's start with the timber section. So we had 360 by 360. We'll select GLT for the timber. For the steel plate, we can start with 12 millimeters. We'll use the same width as the width of the column. For the screw data, we can select the Eurodig screws as we have in the inputs, and we'll use ABS strong plate screws here. Again, more information can be something that can help with selecting the appropriate screw. And we'll use the angle bracket 10 by 180. For analytical methods, we can select Uritic ETA. And here we're going to build the screw geometry. So I'm going to select 15 total screws. So we're going to 5 screws in 3 rows. The end distance I'll set to 150. Then we'll have 80 millimeters here. We can use a long grain 120 and perpendicular 100. And let's check on the top view how this looks. Also on the side view, we can see the thickness of the steel, the position of the screws. If we go down, we have option for the loads. So in this case, I'll type in 108 kilonewtons. And for the design data, we have all information about the gamma, load duration. So we'll use the medium term in this case. Service class will be 1 and pre-drilling will be no. Output summary, we can see that the share capacity, in this case, will actually, we can check the information about the K mode, so it's 0.8, that's okay. So the share capacity is failing in this case on 126%. We can go in details and check what is the requirements about the positioning, with the rope effects information and the calculation, then the share capacity. So we have information about all the mechanism types, design capacity with a summary of what is the total capacity of the screws, and because of the steel to timber connection, we also include the block and plug share failures accordingly. What is also interesting, you can use the slip module values for getting the stiffness of the calculation beside the verification. So we use 15 screws in this case, and we got that we need even more. So we're going to just check the alternatives and see if we can get even less screws that we use, just using the actual capacity of the connection. So I'm going to go back on the next slides, and we'll see how the inclined screws can help us with the design. So in this case, we'll use the same example and the screw actual capacity for designing the same connection. We'll use the different connection module in this example with the same material properties and applied forces. So let's just use the different screw module and see how the inclined screws can help us. So I'll go back on the project level, add calculator, and in this case, we'll use the actual loaded side grain calculation. So as we get this calculation open, we can see here again, we have option with the different design code, but here we have, beside that input, we have option for selecting is it timber to timber or steel to timber connection. We're going to select yes for the steel. We'll type in the same properties for the timber member, GLT material, and for the steel, we'll type in 12 millimeters for thickness, 360 for the width. So we'll cover the geometry as we have on the previous design. For the screw properties, again, we'll use this Uritic screws, but in this case, we'll use the different type of screws. So as we mentioned, we're going to use the fully threaded screws in this case. So let's start with Constru STSK. And so we can start with some of the longer ones, but we'll try to use a less number than we have in the previous example. So let's set 10 by 300, for example, and let's start with the geometry. So in this case, I'll set 45 degrees angle. For the end distances, we can use 120 edge distance. We can go 80 numbers of screws. So we'll try to go with 5 screws in a row and 2 rows for the start. Spacing along the grain, we can go with 120, and along perpendicular, we can go with 200 because we have 2 rows. So we'll try to see if this is something that we can fit. So this is the top view. If we go on the side view, we can see the position of the screws inclined. So this represents the timber column. We have the side steel plate and the inclined screws. If we go to loads, we can type in 108 kilonewtons. I'll just type in the appropriate field. So we have, as we set the inclined screw, we're going to have option for adding the lateral load beside the actual one. And for the design data, again, we're going to use 1.3. We can use medium-term service classes, and for pre-drilling holes, we can say no. In terms of the results, we have the actual capacity, so just the actual capacity of the screws from the actual force. We have geometry check, actual capacity 2 is practically the component of the lateral force that will be checked and what we are using, where we inputted 108 kilonewtons. We have the combined actions and information about the slip modules as well. If we go on the screw geometry, we can check the positioning of the screws. So based on the requirements, we used our appropriate distances, both intermediate and edge one. For the actual capacity, so here are the properties of the screws. So all the information as the minimum of the withdrawal capacity of the point side member and characteristic tensile resistance of the connection. Going further, we have the design capacities here. So we know what is the design capacity of the fastener itself, but here is also along the screw and compared with the along load axis design capacity. So that is something that is being taken into the account. So we have information about projected applied lateral load compared to the total actual force of the fastener. And the last part is in slip modules. But if we go on the summary, we can see that practically we optimize connection on almost 95% with a total of 10 screws compared to the previous example where we have 15 screws that wasn't passing. It was almost on 130%. So just an example how the inclined screws can, with the use of less screws, we can use it for the design of lateral connections and have optimum numbers of screws and geometry. If we go further, we have options of just a preview of the results. We'll have the I'll get over to the last design example in what we prepare for this presentation. So we have some situations where a connection needs to be shifted up to be covered or hidden for the architectural requirements, or because of the fire protection. In this case, we'll have to shift the custom steel bracket up, having a beam notch. We'll have the same maximum reaction force as we have on the previous, of course, and we'll use we'll have this verification with and without reinforcement. So first we'll try without reinforcement, and then we'll see if we need reinforcement. So we'll go back on the app, get back on the project level, and we'll add a beam notch calculator. So we have it in the timber failure group. We can start editing. So in this case, we can firstly type in the appropriate properties of the beam. So we can select GL24C, 360 by 720. We have the support of the beams and columns. So we can have 200 by 200. If we go on the side view, we can check that's basically 80 millimeters on the side. We have the notch by 120, so we can have 580 millimeters here, I think. So we're going to have quite a notch. For this example, we have the notch distance and option for inclination as well. For the design methods, we have the Eurocode, we have the input forces, and we'll first try without reinforcement. So I'll set this for no. For design input, we'll select 108 kilonewtons, and for design data, we have the series classes medium-term action, gamma m can be on 1 in case it's on 1. So if we go on the shear check without reinforcement, we can see that it's on 109%. There is a warning that we need to provide reinforcement because the stress level are too high. So in this case, we can just select the screw reinforcement yes, and we have additional inputs in this case where we can select the appropriate fasteners. So for the screw supplier, in this case, we can try with SIGA products. Again, more information is something that we can use all the time. So current alternatives and possibilities can be seen here. So in this case, I'll use fully threaded with cylindrical cap. So I'll go with GoFix X Plus. So let's go with these products and let's set some of the fully threaded screws. So I'll use 8x400 in this case. I can use the SIGA ETAs. And for screw geometry, I'll just check in what are the requirements. So edge distance is on 40, numbers of screws are 3, and we have the embedded length of 50 millimeters, so it won't be visible from below. If we check the imagery, we can see the positioning of the screws compared to the supporting location. So on the side view, we can also see what are the positioning of the screws compared to the overall geometry of the beam and the notch. If we go on the results, we can see that there's still without reinforcement is just a reminder of that we need the reinforcement in this case. But if we go with reinforcement information, we can check the shear check at the notch area. We can see the reinforcement design and geometry check of the screws that we've been using. In the material properties, we can check the information about the beam that is being checked and the shear check. We have information about the without reinforcement and with reinforcement verifications, geometry check for the type of reinforcement screws we used, and the last part on the reinforcement design is how the tensile force is being taken to the screws and how that being verified. So according to ETA recommendations, we have information about the properties of the screws, and in the last part we have design actual capacity of the screws. So that being said, we can finalize this presentation with just a few closing slides. So Ringo already mentioned some of the things that will come in the next releases, but here is a more detailed overview. So the next release that will be on Monday, we have the CLT compression for columns, walls. Also, GLT compression update will coming with reinforcement options. For the next release that will be in late April or early May, we have open form analysis solution. So this is some of the advanced features that we have a lot of questions and requests. So we'll integrate also the add fire into the beams, columns, walls, and floors. And we have the new architecture for fire calculation, enabling scaling across all the calculators. For the release after that, relating to the connections, we'll have new calculators, including brackets from Eurotech and SIGA, also integration with Plymouth screws and slab-to-wall and wall-to-wall connection details. So we're continuing to scaling up the already implemented connection details, but also adding new ones. So that's also related to one of the next releases that we have. We are updating and making the major UX improvements to all screw modules. We're going to have 3 new major screw suppliers added to the list. Also, we're preparing a USA and Canada connection development, as well as the dowel or bolt moment connection that we are already working on. So I'll stop sharing for the moment. And I'll leave some time for the questions.
Well, Marco, it's awesome, man. Thank you. We've got a few questions here. So everybody, if you want to drop questions, there's a little question mark down the bottom there in the Q&A, and I'll just spotlight them one by one from the bottom up. And so to begin with, I think you did just mention this, but hey, Marco, I see that there are no brackets yet available on Toolbox. How can we best design for brackets?
Yeah, so that's a good question. As I mentioned on the last slide, the bracket design independently will land in our platform soon. First with the Eurotech and Secret brackets. At the moment, you can still use some of the modules that I already showed for the connection design. So if you go with the steel to timber connection modules, you can manually pick up the appropriate screws that you use. You can select the thickness of the bracket, and you can verify the with those calculation the appropriate bracket calculation. So it's a maybe a bit longer process at the moment, but you can still use those values as manually. It won't be ones that are reflected in the ETAs, but it should be very similar values.
Gotcha. And that's primarily in the shear wall design right now, isn't it?
Yeah, but it will be a standalone module, but there will be also available in the share wall design as well.
Awesome. Thanks. Whoever asked that question, if you want clarifications, please feel free. The next one, can you tell us a bit about designing in a seismic zone with the software? What sort of options exist there?
Yeah, that's also a great question. So for the current Eurocode, there are some instructions on the seismic design for the connections. They're mainly related to overstrain factors that can be applied to the design force that are being input. Also, concerning the types of screws that you're using, a lot of producers have specified what screws type land into the appropriate seismic factor, so that can be also checked something, and that also something that we're working through the educational part of our platform. Nevertheless, you can still use our platform for the design. You just need to consider some of these steps into the design process and include your strength factor, appropriate gamma, K modes, and appropriate screws that at the moment you can find on the appropriate from every supplier's website, but something that we will also inform users. New Eurocode, however, lists more provisions and more regulated seismic design. That's something that is still not officially published, so we didn't come up with those calculations at the moment, but also something that we have in mind and we'll have in our pipeline as well.
Gotcha. Yeah, and we also do. We have had a couple of customers who have asked this. We have had a couple who we've helped understand the limitations and what you can do in terms of considering seismic in your calculations. And I think Philip on the call from our team is slowly becoming an expert in walking people through how to do that. So I'll say that that's answered. Will there be the ability to include steel plates in the CLT compression perp to grain release?
For the CLT compression per particular grain, we will not have the steel plates included in this release. We'll have for the GLT compression, but for the CLT, we'll only have the bearing checks for both walls and endpoint loads or columns at the moment. But thanks for the suggestion. It means a lot for us for considering that into some of the updated version of this calculator.
For sure. And we've got a question here as well that I'll just type into the Q&A so I can spotlight it. Where are we? Here you go. So maybe, there you go. Maybe one for you to send us some follow-up on there, Marco, but it could help academically or resources in that sense in the context of timber design.
So yeah, we can follow up that on offline, maybe for a bigger list. We also published on LinkedIn, I think top 15 resources for timber engineering. I think that can be very, very interesting to start with. Mainly, I think for some advanced on the CLT and mass timber, ProHoltz design guides are a good starting point. Also, some of the provisions for the Eurocode explanation and calculation on Eurocode 5. Maybe for the start, but also suggest checking the LinkedIn article that we have for top 15 resources for timber engineering.
Yeah, exactly. And I just sent a link to our website. There's good references for that there too. And then I think we've got maybe one more here. Yep, great. So wondering about fire design for connections. And it's a very popular subject, whoever said that. Yeah.
Yeah, very, very popular. That's also a great point. At the moment, we don't have options for the fire design in our connection design. As I mentioned, as Ringo told at the beginning about our roadmap, we're about to release the fire module in the member calculations. Concerning the connections and the fire, that's something definitely in our roadmap, and we'll have some of the instructions and design according to a current regulation, especially in the new Euro code, because it attack more and have more suggestions on how this can be handled, especially on the connections part, on the screws part, not just on the charring rates and reduce cross section from the timber side. So more about that will come in the next few months and maybe second part of the year. But in the meantime, we'll try to address the current problems with the infrastructure we have. So maybe if you want to reach out to us, we can provide more information directly.
Absolutely. It's a subject that's close to our heart. And we've got Chris Noteboom. Thanks a lot. Greetings from the Netherlands. Thank you. Greetings from Australia and from Serbia. So I'm wondering, I don't think there are any more questions here. So unless anyone else has any questions of their own, of course, as we said, you'll be able to access a copy, you'll be able to access the recording, of this webinar in our community forum. We'll also be chopping it up and putting it onto YouTube in case there are little parts of that were helpful. I'll just show you our next webinar, and we're slowly making our way through basically all the different building types. But our next webinar planned will be on May the 7th, and we'll be covering hybrid CLT and light frame buildings. So we'll be releasing one of our first light frame calculators, a CLT wall calculator, CLT compression calculator, and a CLT shear wall. So thank you, Farshid, thank you for coming to 2 webinars in one day. So to everybody who made the time and has made the time for our webinars so far, thank you so much. We really appreciate it. To all our partners, I see Martin and Daniel on the call from Sodra, so really appreciate you guys being here. And to everybody else, thank you. We'll send through these recordings and we'll see you at the next webinar. So thank you so much.
Thank you, everyone. Have a great day.
All right.
See you on the
Bye.
next webinar.
Bye.